few words about this biofuels course. And today we more or less start with this. I have named this like part A, B, C, and D, but that's not important. But you'll see this in the Moodle as well in front of the section headlines, and also in the syllabus these are listed. So the introduction is more or less like general things about the current situation, how fuels, what kind of position or significance different fuels in our society has, the applications, and later on perhaps a little bit about sustainability, fuel properties, standards. This probably will be on Wednesday. Let's see how much time we have today, or how fast I will speak. Also a little bit about emissions, because that's closely connected to the motivation of using biofuels instead of fossil-based fuels. And part A ends with some kind of glance or glimpse of current today's oil refinery, as that can be understood that it's the current mature dominating technology that the biofuels are partly replacing, but also always it's connected to oil refinery. If it's cheaper or expensive and so on, biofuels it's kind of a new emerging technique that has to compete with oil refinery, and in many cases be slightly better. Luckily, the legislation is on the biofuel side, so maybe also the higher cost somehow acceptable. Second part will be probably next week. So we go a little bit in more detail into the different types of biofuels, the sustainability and potential applications, and also glance through some of the biofuel properties and also the pluses and minuses related to these. So these are not always the perfect solutions when we think about the practical aspects of, let's say, storage and so on. Biomass chemistry is the third part of this course, and this is basically something about the biomass itself, the chemical composition, and how these molecules or biopolymers react, and how to convert these into something useful. And well, that will come. Fourth part is then focusing or giving general overview of the main biofuel production processes. And if you take a look at this syllabus, that there was this two other courses in addition to this. So we'll focus here, or let's say that there are several important biofuel processes which are not dealt here, but are dealt in this waste to fuels or power to X courses. So check which you are interested in and so on. Then the last part of last half of the whole course is then taking more into or studying more in details the actual processes that we discuss in this course. So how the monomers are made from the biopolymers, which type of pre-treatments are applied. And here we focus on, for example, conversion to bioethanol and making or breaking lignin and other non-sugar monomers. Also, the fats and lipids are considered here. So these are called triglycerides. And then few words about the synthesis gas. And here the focus is, of course, in biomass as the raw material for these processes like hydrogen production, methanol synthesis, and Fischer-Tropsch synthesis. That we'll have a look then. This is more about how to convert fats and lipids, so this kind of into fuels by pyrolysis, liquefaction, and also how to. Sorry, now I said this is a bio oil production. Sorry, no, not about fats and lipids. No, well, in any case, so pyrolysis of biomass and which produces bio oils. You go take a look at their, let's say, common general properties and also the process to convert these and some alternatives how this could be upgraded to fuels. And that's about it. Do you have any questions regarding this general contents of the course? Okay, this is something that I also you can find in the Moodle, but the course evaluation, at least at this point, I'm of the opinion that, well, we have these online Zoom lectures, and I would recommend you to join if you can and like, but these are not obligatory. I'll record these, and like Andrea said, so the recordings can be accessed via that Moodle portal somewhere. I did some test recordings and I couldn't find those anywhere, but let's see, hopefully this will not be lost. Also, what is part of the evaluation, at least at the moment, so I have this kind of discussion activities in Moodle, and from each participation and commenting of other discussions, you'll get 3 points from each. Then each course section contains assignments, and at the moment there are in total 9 assignments, so you'll get some points by completing those assignments. Then I thought that this kind of, we don't have any final exam, but you would make some sort of project work that would be part of the evaluation. And also everybody will one way or another present their project work to others, and that's also part of the grade. So I'll try to give quite many journal articles as course material to you. And this also what I have named the course book. So it's already nearly 20-year-old publication, but it contains many of these key elements that we go through during the course. So therefore, I'm keeping it as the so-called course book or textbook material. And of course, some of the numbers and things have evolved since the publication of this, but therefore I also tend to add other materials in Moodle which are part of the course and are more, let's say, up to date, or maybe telling more details about things that are not necessarily mentioned in the course book. The resolution is not the best, but here you'll see roughly similar things that I already presented to you. So we start with biomass chemistry related things. So you should get a kind of idea what lignocellulose is made of, what cellulose, hemicellulose, lignin, chemical-wise, what's the composition, and what type of functional groups and active centers are in those materials that can be then broken to monomers that are then used to make some useful fuels. Also here are these triglycerides, algae, terpenes, rubber-producing plants, and so on. Then more about these techniques like gasification, syngas utilization, or what I mentioned, like making of hydrogen, methanol, and Fischer-Tropsch synthetic fuels. And then the bio-oils via pyrolysis are dealt here. Also the potential upgrading methods, and chapter 7 is dealing with the biomass monomer production, and that is basically breaking the biopolymers into smaller fractions. It can be called like pretreatment, it can be chemically hydrolysis, and so on. But the idea is to make this very long polymeric biomaterials into smaller molecules or things that can be then processed easier. This looks strange, but sugar conversion, that's the classical biofuel production process where you end up with bioethanol. That has been, it's one of the oldest so-called biofuels, I suppose, that are still quite a lot in use. Asem, you had maybe a question.
I have a basic information about the gasification and pyrolysis. And as I know, the main application for them is waste to energy application. Am I right or not?
Yes, those are used there as well. And these are like, here the angle is the biomass into something. And often the pyrolysis or gasification can be also used in the classical oil refinery and utilizing fossil-based raw materials. But we'll take a look at the applications also later. But here we are more interested and focused on the bio, how to convert biomass instead of, let's say, coal or oil or something like that.
Okay. Thank you.
Yeah. So then chapter 9 is so-called non-sugar monomers. So this non-sugar comes from the fact that the lignocellulose, like the woody biomass, it's basically sugar polymers. So glucose and many other sugar materials. And then these non-sugar materials are from the lignin. Lignin is made from aromatic benzene type monomeric components. So therefore it's not sugar, but it's an aromatic ether, aromatic alcohols and such kind of monomeric building blocks. Therefore it's called non-sugar. These lignin materials are a side product from pulp and paper industry. At the moment, it's, at least in Finland, it's burnt and the energy is used in the paper making process, but it's also valuable material that can be converted to particularly aromatic components. Triglyceride are all sorts of fats and oils, vegetable oils and animal fats and such kind of things, and their conversion we'll take a look